Okay, starting here, we are going to set up our hypothesis. And remember, your null, which is H0, it always will have the equal portion in it. So it'll either be less than or equal to, greater than or equal to, or equal to. So here it says, suppose a university advertises that its average class is 35 or less. So 35 or less means it can be less than or equal to 35. So that is our null. Well, the opposite of that, if it's not less than or equal to 35, would be, your alternative would be greater than 35. So we already know that this is a one-tailed test. And if we were to draw this just using 35, it would be your alternate or your critical area is going to be the greater than side. So we already know that this is going to be our area of rejection. Okay, so now once you set up the hypothesis, the rest of it is just like the other videos that I did, the one tail. Well, you have a random sample of 39 classes, so that would be N, and the average class size was found to be 37.1, so that's X bar, that's your sample mean. Your standard deviation is 7. And then alpha is 0.01. So we're going to take all of our information and fill it in. So let me move this down so you can see it. Okay, so let's go through and fill in what we know. So our mean, let me see if I have this written down so I don't have to flip back and forth. So our sample mean is 37.1. I'm just going to double check. Okay, yeah. So 37.1. And I'm going to try a different color here. All right. And then our mean of the sampling distribution, which is in our hypothesis, is 35. Our standard deviation is 7. N is 39. And alpha is 0.01. So if we plug that in to get our test statistic, we're going to get 37.1 minus 35, and then over the standard deviation, which is 7 divided by the square root of N, which is 39. So I'm not going to put that in Excel to show you how to calculate it, since we have done that several times. But you should get 1.87 for your test statistic. So that's what we're going to test. Okay, once you have your test statistic, you can put that into your homework. So that's the second part of A, 1.87. Now we need to do our critical z-score. This is a one-tailed test, and alpha is 0.01. So if we go to our page in our book or in your PowerPoint, you can, I think it's chapter 8, 0.01, our critical value is 2.33. This is on page 344 in the textbook. So 2.33 is our critical value. Okay, so since our test statistics, 1.87 would be somewhere to the left of it, so it's not in the rejection area. So we would not reject it. So since it's less than the critical value, do not reject the null. Now for the p-value, since we have a positive test statistic, we're going to have to say 1 minus, because what it's going to give us is it's going to give us to the right of this. And we know both of these add up to 1. So whatever we look up in the table, we're going to do 1 minus that, or whatever. We're going to use Excel. So our test statistic was 1.87, I believe. So 1.87, and we want it to be cumulative. Well, that is going to be the side, the left side, the less than side. We want the greater than side, so 1 minus that. So your p-value is going to be 0.031. So let's look at it. 0.031 for your p-value. All right, question 6 is a two-tail test, and you're going to do equal to, not equal to, because it says the average adult drinks 1.8 cups of coffee per day. So it's going to equal 1.8 or not equal 1.8. You would use your test statistic, 0.97. You would use the formula. Then your critical z-score, since alpha is 0.01, you could look that up. So remember, if it's two tails, 0.01 divided by 2 would be 0.005. So your critical value is 2.575. But we're going to round it to 2. So you're going to have 2.58 and negative 2.58. Well, let's think about that for a second. Since it's a two-tail test, let's look at how that would fall. So negative 2.58 and positive 2.58. And these are your, let me get the highlighter. These are your rejection areas. But our test statistic, if we used our formula, would be 0.97. 0.97 is bigger than negative 2.58 and less than 2.58. So since it falls in between these, we are not going to reject it. So it falls within the critical values, do not reject. To get your p-value, what you could do is use the negative one, because then we don't have to subtract. So let's do the negative 2.58. Now, what we need to do is, it's a two-tailed test, so we need to say 0.005 times 2. And you would get 0.01. Okay, I did something wrong. Your p-value, I think I put the wrong thing in for the test statistic. Our test statistic, I used the critical value, which is a good thing I did, because that's a mistake that a lot of people make. You make sure you use your test statistic. Now, since it's positive, we do have to say equals 1 minus this. So we end up with 0.166, and we have to times it by 2. So we end up getting 0.332 for our p-value. Okay, and then question 7. It says that the average delivery time for orders is under 44 minutes. Under means less than. The less than would have to go in the alternative hypothesis. So what goes in the null? Well, what's the opposite of less than? Well, any 44 and above. So greater than or equal to. Now you see we have a one-tailed test. Our test statistic is negative 2.14. Now that you know how to do the test statistic, I'm not going to use the formula. Just assume we used it already. And the alternate says less than 44. So it's a one-tailed test and it's the less than. So this is the rejection area. If we do our critical value, it's negative 1.28. And our test statistic was negative 2.14. Well, negative 2.14 would be smaller to the left of this, so it is in the rejection area. So, since our test statistic is less than the critical value, we would reject. Now, the p-value. So, make sure you use the test statistic, negative 2.14. Since it's negative, we don't have to subtract from 1. So I'm going to delete that. So our p-value is 0.016. 0.016. Okay, question 8. It says that the average is 36 or less. So that means less than or equal to 36. That's how we got our null. So the opposite of that would be greater than. And then you just go through the steps like we discussed. Okay. Question 9. Question 9 is basically the same thing, but they do show you how to use the formula in Excel to get the test statistic, but technically I believe this is the one. Yes, so this formula is actually what I was doing anyway. It's just taking your formula and plugging it into Excel. I will do another video on that, and I'll show you how to work 9 and 10 using Excel. Even though I have been using that formula technically already, when we got the test statistic, I showed you in Excel how I got my test statistic. It's the same thing, but the difference is we're going to format it with labels. Okay, so I will do that in the next video, and that will be the final video for section 9.2.